Today, we're going to discuss separable differential equations, or in some other books, they call that one as separation of variables. So to start with, let us define what is the meaning of separable differential equations. A separable differential equation is any equation that can be written in the form of y prime is equal to f of x times g of y. So the term separable, it refers to the fact that the right-hand side of equation can be separated into a function of x times a function of y. So how are we going to solve this kind of a topic, which is the separation of variable? So first, we are going to check for any values of y that make g of y is equal to 0. So this corresponds to constant solution. Number two, rewrite the differential equation in the form of dy over g of y is equal to f of x dx. So in this form, we combine together all y and we combine all together in terms of x. So after that, we have to integrate both sides of the equation. Then step number 4, solve the resulting equation for y if possible. And number 5, if an initial condition exists, then substitute the appropriate value for x and y into the equation and solve for the constant. Okay, so this is number 1 example. Find a general solution to the differential equation of y prime equals x squared minus 4 times 3y plus 2 using the method of separation of variable. Okay, comparing the given equation from this formula of y prime equals f of x times g of y, our f of x now will become x squared minus 4 and g of y equals 3y plus 2. Or I can write this one. So this one is our f of x, and the other one, we have 3y plus 2 is our g of y. So according to the rules, so step 1, we're going to check for any values of y that make g of y is equal to 0, because this will correspond to constant solution. So what I'm going to do is that we are going to so using step number 1, okay, we're going to let g of y is equal to 0. Then, if g of y is equal to 0, so I can write now we have 3y plus 2, which is the value of g of y is equal to 0, and then solve for y. So we have 3y is equal to negative 2, and solve for y. So y now equals negative 2 over 3. So that 2 value of y, which is equal to negative 2 over 3, is what we called as a constant solution. Now, after using that step 1, we're going to rewrite the differential equation in the form of d of y over g of y is equal to f of x dx. So that is now step number 2. So using step number 2 now, we can write, okay, from the given of y prime is equal to x squared minus 4 times 3y plus 2, or I could write y prime instead of dy over dx is equal to x squared minus 4 times 3y plus 2. So we're going to combine together all y and in terms of x. So that could be in this form, dy over g of y is equal to f of x dx. So writing that one, I will use first cross multiplication, and this will be equal to dy is equal to x squared minus 4 times 3y plus 2 of dx. But in this side, in the right hand side, we have here, still we have 3y plus 2. that is now the quantity of 3y plus 2, will be removed in the right hand side in such a way we are going to group this one together in terms of y. So therefore, I'm going to divide both sides by 3y plus 2. So 1 over 3y plus 2. So the product now will become dy over 3y plus 2 is equal to x squared minus 4 of dx. That's the long method on how are we going to separate the variables. The word separation of variables, it simply tells us that we are going to group together in terms of y and group together in terms of x. So in short class, we are just going to, from the given equation of dy over dx equals x squared minus 4 times 3y plus 2. So the 3y plus 2 will be grouped together in terms of dy. So you have to divide both sides by 3y plus 2. In short, you can put that one in the denominator of dy, which is now the 3y plus 2. And using cross multiplication, we have now x squared minus 4 times dx. That's why we have here x squared minus 4 times dx on the right hand side. Now, after we have separated the variables, now that's a time we're going to integrate. And that is now our step number 3. So I will write here, this is our step number 2. And then step number 3 is to integrate. So integrating now both sides, we have dy over 3y plus 2 is equal to the integral of x squared minus 4 of dx. Now to solve on the left hand side, we are going to let u equals 3y plus 2 and du is equal to 3dy. Now comparing this value of dy to our given, so dy is visible in our given, and we also have dy from our du, which is now equals 3dy. Since dy is visible, then we need to divide both sides by 3. So dividing both sides by 3. So therefore, we have defined dy is equal to du over 3. So to solve for that now, so from step number 3, we have now the integral of dy over 3y plus 2 is equal to the integral of x squared minus 4 of dx. So we know that dy can be replaced now by du over 3. So we have the integral of du over 3 all over the meaning of 3y plus 2 is our u. So that's why we have now the integral of du over 3 all over u is equal to the integral of x squared minus 4 of dx. So simplifying the left hand side, so we can write now 1/3 times the integral of du over u is equal to the integral of x squared minus 4 dx. Now, we are going to integrate both sides. So therefore, this will become 1/3 ln of the absolute value of u is equal to x cubed over 3 minus 4x plus a constant. Now, since we have a denominator of 3, then I'm going to multiply the entire equation by 3 to avoid denominator of 3. So therefore, we have now 3 times 1/3 is equals to 1. So we can just have here ln of the absolute value of u. 3 divided by 3 is 1 times the numerator. So we have now the product is x cubed minus 3 times negative 4x. We have negative 12x plus 3 times c is 3c. Now from there, we are going to let c sub 1 is equal to 3c. So if we let c sub 1 equals 3c, then the new equation now will become ln of the absolute value of u equals x cubed minus 12x plus c sub 1. Now, in order for us to eliminate the ln, so we are going to exponentiate both sides of the equation. At the same time, I'm going to substitute back the meaning of u. So we can write now e raised to the ln of the meaning of u a while ago is 3y plus 2 is equal to e raised to x cubed minus 12x plus c sub 1. Okay, as I've said earlier, we are going to exponentiate both sides of the equation in order for us to eliminate the e and to the power of ln. So the left hand side now will give us the answer of the absolute value of 3y plus 2 is equal to e raised to x cubed minus 12x plus c sub 1. So we am going to separate the exponents of x cubed minus 12x grouped together and the c sub 1. So we are going to write here as the absolute value of 3y plus 2 is equal to e raised to x cubed minus 12x times e raised to c sub 1. So after that, I'm going to let another variable. I'm going to let now c sub 2 is equal to e raised to c sub 1. Now, if I'm going to replace e c sub 1 by c sub 2, then the new equation now will become the absolute value of 3y plus 2 is equal to c sub 2 times e raised to x cubed minus 12x. Since we have absolute value in the left hand side, so we can have two possible equations. So the first one can be 3y plus 2 is equal to c sub 2 of e raised to x cubed minus 12x. And the other one, we have 3y plus 2 is equal to the negative of c sub 2 of e raised to x cubed minus 12x. Now, if we are going to solve for y, then we are going to transpose. Okay, I will just rewrite the last two equations from the other slide. This one, we have these two. So I will just copy this one, 12x. Now, if we want to solve for y, so we need to transpose positive 2 to the other side. So we can write now 3y is equal to negative 2. And this can be plus or minus if I'm going to combine the two equations on the right hand side. So the positive is this one and the negative is on the second equation. So combining that one now, we can write negative 2 plus or minus c sub 2 of e raised to x cubed minus 12x. Now solving for y, we need to divide both sides by 3. So therefore, y is equal to negative 2 plus and minus c sub 2 of e raised to x cubed minus 12x all over 3. Now, if I'm going to let another variable, if I'm going to let c is equal to plus or minus c sub 2, then we can write the new equation now of y is equal to negative 2 plus or minus c of e raised to x cubed minus 12x. So that is now our general solution to the differential equation. Okay, next problem. We are asked to obtain the general solution of xy cubed dx plus e raised to x squared dy is equal to 0. So if you're going to manipulate, we need to divide the entire equation by y cubed. And then after that, we divide also by e raised to x squared. So the resulting equation now will become x dx over e raised to x squared plus dy over y cubed is equal to 0. Then after that, we are going to rewrite this one in terms of e raised to the power of negative x squared times x dx plus y to the power of negative 3 dy is equal to 0. And then we are going to integrate. Now, on the first term, we need to let u equals negative x squared. So the derivative of negative x squared equals negative 2x dx. Now, comparing the value of du to our given, we can see that there is common between the two, which is now x dx. So we need to solve now for x dx. So we need to divide by negative 2. So therefore, du over negative 2 is equal to x dx. So rewriting now our given, so we can write now here the integral of e raised to u, because the meaning of negative x squared is u, and the meaning of x dx, which is now times du over negative 2. And I will just copy the second term, which is now the integral of y to the power of negative 3 dy is equal to 0. Now, simplifying the first term, we can write now negative 1 half the integral of e raised to u du plus the integral of y to the power of negative 3 dy is equal to 0. So integrating the terms now, we can have negative 1 half of e raised to u plus y to the power of negative 2 over negative 2 is equal to c over negative 2. Why do I write c over negative 2? Okay, I need to write there as c over negative 2 in such a way we are anticipating that the negative 2 will be eliminated. So if we are going to multiply now the entire equation by negative 2, that's the time we can eliminate the negative 2 and it will give us the original answer of C. So that's the reason why I write there C over negative 2. Now, multiplying the entire equation by negative 2, so this will give us negative 2 times negative 1 half of e raised to u is equal to e raised to u, and negative 2 divided by negative 2 is cancelled. Therefore, that's only 1. So plus y to the power of negative 2 as well as negative 2 divided by negative 2 on the right hand side, that will be cancelled. So the remaining answer is just C. Now let us substitute back the meaning of u. So the meaning of u is negative x squared. So I can write now e raised to the negative x squared plus y to the power of negative 2 is equal to c. So this is now our general solution. Okay, the next problem is y e raised to 2x dx equals the quantity of 4 plus e raised to 2x dy. So if we are going to manipulate that one, so we can remain here on the left hand side, we can remain the e raised to 2x. So we can write e raised to 2x dx. Then we can also remain here on the right hand side just dy. And then since we have y on the left hand side, so we have to divide both sides by y. So your y now becomes will be written on the right hand side. We have dy over y and the quantity of 4 plus e raised to 2x. So to eliminate that one in the right hand side, we need to divide both sides by 4 plus e raised to 2x. That is why we can write the quantity of 4 plus e raised to 2x in the denominator of e raised to 2x dx. So we can write now 4 plus e raised to 2x as a denominator of e raised to 2x dx. So after we have separated the variables, then we are now going to integrate. Now to solve for the left hand side, so we are going to let u is equal to 4 plus e raised to 2x, and the derivative of 4 plus e raised to 2x, derivative of 4 is 0, and the derivative of e raised to 2x is just equal to 2 e raised to 2x dx. Now comparing now the value of du to to the given of e raised to 2x dx. So they are similar with e raised to 2x dx. So we need to define that one. So we have to divide to both sides. That's why we have du over 2 is equal to e raised to 2x dx. Now by substitution, we can write now as the integral of, so we can replace now e raised to 2x dx by du over 2 all over the denominator of 4 plus e raised to 2x is equal to u. So we can write u is equal to the integral of dy over y. So simplifying that one, so we can write now 1/2 is outside the integral sign. So we can write it here. So we have 1/2 the integral of du over u is equal to the integral of dy over y. Now, we have to take the integration. So we can write now 1/2 ln of the absolute value of u is equal to ln to the absolute value of y plus, I'm going to, instead of writing c, so I will write here now as ln of c, since the left hand side and the right hand side have both ln, so therefore I will write here ln of c instead of c alone. Now, after that, we are going to eliminate the denominator of 2. So to eliminate the denominator of 2, we are going to multiply the entire equation by 2. So by using distributive property, so this will give us the product of ln of the absolute value of u is equal to 2 times the product of ln of the absolute value of y plus ln of c. So I will simplify first on the right hand side. So we can write now the ln of the absolute value of u is equal to ln of cy by applying the properties of natural logarithm. So we can have now ln of u is equal to 2 ln of cy. And applying again to the power rule of the natural logarithm. So we can write now as ln of the absolute value of u is equal to ln of the quantity of cy to the power of 2. Now after that, since both sides of the equations have ln, so we can apply the property of equality. So we can cancel ln both sides. So we can write now the absolute value of u is equal to cy, the quantity of cy, the power of 2. So we are going to substitute back the meaning of u, which is actually, we have 4 plus e raised to 2x is equal to the square of cy. So that is now our solution for this problem. So next we have the quantity of xy plus x dx is equal to x squared y squared plus x squared plus y squared plus 1 of dy. So first, I'm going to factor out the left-hand side in terms of x because x is common. So I can write now x times y plus 1 of dx is equal to, so the factor now of the right hand side, as we can see that x squared y squared is a perfect square, and the last term of 1 is also a perfect square. So I'm just going to separate the first term and the last term. So we can write here as x squared, and then separating x squared y squared, so the other one is y squared, and then the factor of 1 is 1. So we have 1 and 1. So they are both positive because the sign here in the middle term, we have this one will be grouped together. So we have now, they are both positive. So the factors now of the given quantity of x squared y squared plus x squared plus y squared plus 1 is the product of x squared plus 1 times y squared plus 1. Now if you are going to check whether this factors is correct, now you can use the FOIL method. Let's try. So x squared times y squared is x squared y squared Outer terms, x squared times 1 is x squared. Inner terms, 1 times y squared is y squared. And the product of the last term, which is 1 times 1, is equal to 1. So therefore, the factored form is correct. Now, after that, we're going now to manipulate in such a way we combine all x and we combine all y. So in this case, this can be written now as x dx over x squared plus 1 is equal to y squared plus 1 of dy over y plus 1. Now, okay, by inspection, the degree of polynomial in the numerator and the right-hand side is greater than compared to the degree of the denominator. So in that case, we are going to divide using the long division. So for this, we can now write here as y squared plus 1 divided by y plus 1. So y squared plus 1 divided by y plus 1. So we can write now y as the quotient. Then multiply using distributive property. So y times y is y squared. Y times 1 is y. Then subtract and change the sign of the subtrahend. This will be negative and this will be negative. And then add. So this will be cancelled. Y squared and negative y squared is 0. And then the other term, we have 1 and negative y. So I can write first as negative y plus 1. So the degree of this is a first degree and our divisor also is a first degree. So still we can divide because we can only divide if the degree of the numerator is greater than or equal to the degree of the denominator. Since they are equal, now they are the same degree, so we can divide it further. So negative y plus 1 divided by y plus 1, or you may concentrate first the first term. So negative y divided by y equals negative 1. And then using distributive property, so negative times y is negative y, and negative times 1 is negative 1, and then subtract and change the sign of the subtrahend. This becomes now positive, and this is also another positive. So therefore, this is now additive inverse. So negative y and positive y is 0, and positive 1 and positive 1. So we have now the remainder of 2. So after we get now the quotient on the right hand side, so we can rewrite now our equation in terms of the integral of, okay, we have now the integral of x dx over x squared plus 1 equals the integral of y minus 1 plus 2 over y plus 1 of dy. So we are writing here the quotient of y squared plus 1 over y plus 1. So next is I'm going to expand or separate the two terms on the right hand side. So rewriting again, we have now the integral of x dx over x squared plus 1 is equal to the integral of 1 minus 1 of dy plus the integral of 2 over y plus 1 of dy. Now to solve for that, we can, in the first term, we let now we let u is equal to x squared plus 1. So derivative of u now equals to 2x dx. So x dx is visible in our given. So let us define now x dx. So divide by 2 both sides. So therefore, x dx is equal to du over 2. On the first term on the right hand side, so we can just integrate that one easily. But on the second term, we need to let w is equal to y plus 1. Now, derivative of w is dw, and derivative of y plus 1 is just equal to dy. Now, by substitution, the left-hand side and on the second term on the right-hand side, so we can write now as the integral of, so we have the integral of, the meaning of x dx now is du over 2 all over u. That's the meaning of x squared plus 1 is u. Then is equal to the integral of y minus 1 of dy plus we have now 2 the integral of dy means dw over y plus 1 is w. Now integrating now together all the terms. So we can write now 1 half the integral of du over u, which means ln of u, ln of the absolute value of u is equal to the integral of y minus 1 is we have y squared over 2 minus y plus the integral of the last term we have 2 ln of w plus ln of a constant. So to eliminate the denominator of 2, so I need to multiply the entire equation by 2. So I'll copy that one first. We have now ln of a constant. So I write ln of a constant for us to eliminate the ln later on because we have ln on the left hand side as well as we have ln on the second term. So to eliminate the denominator of 2, so we need to multiply the entire equation by 2. So the product now we have ln of the absolute value of u is equal to y squared minus 2y plus 2 times 2 is 4. So we have 4 ln of w plus 2 times ln of c, we have 2 ln of c. So next is we are going to substitute back the meaning of u and w. At the same time, we are going to apply the power rule on the last term. So we can write now ln of u. Our meaning of u a while ago is x squared plus 1 for the first term. We have x squared plus 1 is equal to y squared minus 2y plus 4 ln of the meaning of w there is y plus 1 plus 2. We can write now, instead of writing 2 ln c, we can use power rule. So we have now ln of c squared. Now after that, we are going to combine the second term and the last term. So using the properties of natural logarithm. So I will rewrite this one first as ln of the absolute value of x squared plus 1 is equal to y squared minus 2y plus 4 ln of the absolute value of c squared times y plus 1. So we applied a product rule for the properties of natural logarithm. So we have now the final answer of ln of the absolute value of x squared plus 1 is equal to y squared minus 2y plus 4 ln of the product of c squared and y plus 1.